Hey guys, my name is Paul, and I'm here to seek your support for Myst Fireproofing, a safe, effective, and affordable way to protect your homes against fires. We've developed a flame retardant powder that you can mix with water and then dip, brush, or spray onto wood, fabrics, or thatch to make them much harder of catching fire. It is odorless, it dries clear, and it will stay in place unless it's getting washed out by water over time. You can use it inside on furniture, Christmas trees, draperies, or outside on the wood siding of your house. So I started this project earlier this year after seeing blocks of homes going up in smoke in the devastating LA fires. I lived and studied in California, so I wanted to do something about it. And the problem is only getting worse in many parts of the world as the weather gets drier and hotter in those places. It turns out that there are existing flame retardants that you can apply to your home maybe once a year before the fire season starts to decrease their chance of catching fire from a violent fire. The problem is that these products are not well known and they're really expensive. I'm doing an Amazon search for flame retardants. Look at this. $16 for a small 22-ounce bottle. That's over $90 for a gallon. This one, $65 for a gallon. Let's see. Wow. More than $200 for 5 gallons. That's a little under $60 for a gallon. Needless to say, flame retardants are really expensive. My day job, I work as an electrical engineer that makes AI software for designing computer chips. So for this job, I had to put on my chemist hat. For that, I enlisted the help of a leading fire safety laboratory at a local university. And together we were able to come up with a formulation mostly from the open literature. We adapted formulations that have been used for many years and have been tested and proven. The result is a formulation that's safe, effective, and sourced from commodity chemicals that have been well known and well studied. So here I've set up an informal demonstration. On the left is our control sample, which is not going to be treated. And on the right is our test sample that we will spray with our flame retardant. So as you can see, it's just a thin piece of wood. Okay, so we're gonna spray on our fire retardant. Everything has thoroughly dried. Let's put it to the test. Here I have a blowtorch that will output a very intense flame. So on the left is untreated and on the right is treated. Let's see. So the untreated sample has already caught fire. And it's attempting to burn the treated sample. I'm gonna put out the fire. Now let's test the treated sample. So as you can see, the treated sample chars, but it does not continue to burn. Even if it catches fire, it fizzles out. So the untreated sample caught fire and we had to put it out. And you can see where it went burnt through, right? It's totally disintegrating. But for the treated sample, yes, it did char, but the char actually forms a protective layer that insulates the wood underneath. And if we try to break it apart, it's 100% intact. So you can see that the char layer is only skin deep. Everything official, we posted our test results to Facebook. Just kidding. To make it official, we conducted a fire combustion test at an accredited laboratory based on the ASTM E84 standard. Now, the ASTM stands for the American Society for Testing and Materials. ASTM E84 is the most common combustion standard for characterizing building materials. Here is an actual photograph of our specimen being loaded into what's called a Steiner panel. Our specimen is a bare wooden board that's been brushed with our flame retardant at a loading ratio of about a gallon or 400 square feet. How this works is the Steiner funnel will inject flame at one end, so lighting one end on fire, and we will monitor how far the flame spreads, known as the flame spread index, and how much smoke is developed, known as the smoke development index. Here you can see our sample getting a baptism by fire in the fiery inferno of the Steiner tunnel. There are actually ports on the side to monitor the progress of the fire down the length. Is this official ASTM E84 Class A certification. Here you can see that our flame spread index is 5 and our smoke development index is 30 compared to the Class A limits of 25 for FSI and 450 for SDI. So as you can see, our performance well surpasses the standards of Class A under ASTM E84. So this is really an excellent flame retardant. Here's the flame spread chart of our ASTM E84 test. The red line indicates the control sample of an untreated red oak plank. As you can see, it catches fire right away in under a minute, and the fire progresses steadily down its length. Whereas for our example, it withstood the rigors of the inferno for more than 7 minutes. The surface is charring, but the char layer actually is protecting and insulating the wood underneath. And for more than 7 minutes, the flame does not spread. And only afterwards is it spreading in a linear fashion. And this is really an excellent test result that gave us a very low fire spread index. So all the groundwork has been laid. Now we just need your support to bring our product to life. Currently, we are fulfilling a small number of orders from friends and family, basically from the inside of a garage. But with your support, we can rent a proper industrial warehousing space where we can set up a powder packaging line. And from there, we can scale up our operations and make a difference to millions of Americans and their homes. Thank you.